Hi everybody, welcome back. Today we're going to look at section 2.4, go over some more problems on this product and quotient rule. So watching the intro video, Dr. Taylor went over with you the formulas and went over a few problems of each type. So that's kind of where we're going to pick up from. Okay, so remember for your product rule, okay, just to review, hopefully you've been doing this a few times. But when you're finding the derivative of a product of two functions, the derivative formula says take the derivative of the first function times the original second function and then add to it the first function, the original function, and then times the derivative of the second function. Okay, so that's kind of the rule for all of these. And we like to do this way because you're always beginning and ending with a derivative. And so that kind of just keeps you consistent along the way. All right, so I know that he went over some of these problems with you. So I'm going to jump down to the next page, 56, and look at number 3 with you just to review this product rule again. Okay. All right, so we are looking at number 3 that says, find the derivative of the function f of x when f of x is the product of two functions. So here's the first function, x to the 4th plus the square root of x, times the second function would be 5x minus 1. Okay, so to do the derivative, okay, remember we're going to start with the derivative always first. So you always start with the derivative of the first function. So this is a sum of two numbers, so we're just going to do the power rule. So this would be 4x to the 3rd power plus, and then remember this is x to the 1/2. So the derivative of that, I'll write that right there, right? That's x to the 1/2. So the derivative would be bring the 1/2 out front and subtract 1 from the exponent, which would give you negative 1/2. So there's the derivative of the first function. We're going to multiply that times the second function. You don't do anything to the second function in this step. Then always a plus sign in the middle. Then you take the first function just the way it is. And then you're going to multiply that by the derivative of the second function. Well, the derivative of 5x minus 1 is just 5. It's just a linear term. And the derivative of negative 1 obviously is 0. So the derivative is just 5. Okay? And remember, just leave it like that. Unless we ask you to do something with the derivative, you do not have to simplify or do anything to these. So that would be your answer for number 3. All right, let's try number 4. Function is x squared times the cosine of x. So one of the things you guys have to be good at is just picking out your functions. So the first function, x squared, times the second function, cosine of x, right? All right, so do the derivative. We're going to start with the derivative of x squared, which is 2x, times the second function, which is just cosine of x, leave that alone, plus, then you're going to take the first function the way it is, times the derivative of the second function. Derivative of cosine is negative sine, so there is your derivative. Leave it like that. Now, it's fine if you want to clean them up, but you do not have to. Okay. All right, number 5 is the product of the sine of x times the cosine of x. So we are going to do the product rule. So the derivative would be starting with the derivative of the first function. So the derivative of sine is the cosine of x times the second function, which is just the cosine of x, plus, then we're going to write down the first function, sine of x, okay, times the derivative of cosine, which is negative sine. And again, that is all you have to write. Okay, now, could you write this cosine squared x minus sine squared x? Yes, that's fine, but if we don't ask you to do that, you don't need to do that. Okay, so you'll know when it's time to simplify and do that. All right, so that was the product rule. Now we're going to look at the quotient rule. Just go over the rule and then we'll do a couple of those. So the quotient rule is very similar to the product rule. The top almost looks exactly the same except for that minus sign in the middle. So the rule for quotients when you're dividing, you always start with the derivative of the top. It's real important that you do the top first. So the derivative of the top times the bottom, which is right here, and then always a minus sign. Then you do the top times the derivative of the bottom, okay? The difference is you're going to write this as a fraction. It'll be over and then just the bottom squared. No derivative in the bottom. Whatever's in the bottom, you're just going to square it, okay? So that's the rule for quotients. Now, before we do our problem, I just want to remind you of the note in the middle of page 58. We just said this earlier. You should leave your answer in this form unless you're asked to clean it up. And when we say clean it up, that's because you're going to be plugging in numbers or using it in another situation. Okay? So you don't have to, as long as, you know, we're not using it for anything else other than finding the derivative. All right, so we're going to jump to number 8, I believe, is the next one that I'll work with you. That's a quotient rule. Okay. All right, so let's do the derivative quotient. So we have this function divided by this function. So we start with the derivative of the top function. So what is the derivative of x to the 4th minus 8x? Okay, so we're going to do the derivative would be 4x cubed minus 8. Okay, that is the derivative of this times the bottom, the way it is. Now this one will always have a minus sign. Then you write down the top function the way it is. And then times the derivative of the bottom. Well, the derivative of the bottom function is just 2. And then that whole thing will go over the bottom squared. So 2x minus 1 squared. Okay. So again, we're really grateful for these shortcut formulas because think about doing this using the definition of derivative. You know, the f of x plus h minus f of x over h, that limit problem. That would be quite fun to do on paper, which you can do, but the shortcuts make it a lot nicer. All right, number 9, quotient, sine x over cosine x, okay? All right, so we're going to do g prime. We're going to start with the derivative of the top. So the derivative of sine is cosine of x times the bottom, okay, minus the top, sine of x, times the derivative of the bottom, which is negative sine of x, all over the bottom squared. Okay, remember if you're putting that in WebWorks, all of these would need parentheses around them, right? The argument, we don't have to write them on paper, but if you're putting this in WebWorks, then yes, they have to have parentheses. All right, now, just a little sidebar on this one. Some of you might say, well, if you remember trig, the sine over the cosine is the same thing as tangent, right? That's the same thing. Well, what is your derivative of tangent and what did this come out to be? So let's kind of think about that. The derivative of tangent is secant squared, right? Well, let's look at what we have here. Cosine times cosine is cosine squared. And then you have a negative sine of x and negative sine of x. That actually gives you plus sine of x, right? So plus sine squared, and then over cosine squared. Well, if you remember your Pythagorean identities, this numerator equals 1, right? Cosine squared plus sine squared always equals 1. Okay. And 1 over the cosine is the same exact thing as secant squared. So if you change this to the tangent and you know, so now this no longer is a quotient rule, and you know the derivative of tangent is secant squared, that's exactly what this is. Okay, it's just not simplified, but those are the same exact thing. Okay, but if you just treated it from here to here, that is perfectly okay. Sometimes knowing those trig functions is helpful if you want to simplify it ahead of time. All right, then Dr. Taylor did a problem with you that was kind of a combination of quotient and product. So he did number 10 with you, and so we have one more to do that's kind of very similar to his number 10, just to kind of practice what happens when you have, you know, a big problem, which it's doable. You just have to take your time and watch your steps. So let's look at number 11. Okay, so we have the sine of x divided by the square root of x. So that's a division problem right there. I'm going to put parentheses around that. And then we're multiplying that by x squared plus 2x. So we're actually going to do the product rule. We're going to do this times this, because that's the big function, is that we're multiplying. But within the product rule, when we take the derivative of the first term, we're going to have to do a quotient rule. Okay, so just got to keep up with what is what. So this is L of x, so we'll do L prime of x. Okay, all right, so product, we're thinking of this as a product, this times this. So if we're doing the product rule, the first rule is to take the derivative of this. Okay, so that's what we're going to do. What is the derivative of the sine of x over the square root of x? So that's a quotient, so we'll do the quotient rule. Okay, so we start with the derivative of the top, which is the cosine of x times the bottom, minus the top times the derivative of the bottom. Remember, the derivative of the square root of x is 1/2 x to the negative 1/2. You can write that as 1 over 2 square root of x. That's fine. Okay, over the bottom squared. Now, what is the square root of x squared? You could also write that as x, but I'm just, again, we don't have to simplify. Now, remember what we just did. That's the derivative of the first. I'm going to put that in brackets. That's the derivative of the first. Now we'll do times the second. So that's the first part of the product rule. And now plus the first, which is that function, times the derivative of this function. Well, the derivative of that's a little bit easier. It's 2x plus 2. Okay, so there is your derivative. Okay, so look at that. So I always tell you guys, when you're doing product rule, there's 4 parts, right? So 4 parts would be the derivative of the first times the second, plus the first function times the derivative of the second. So these two should be the functions that you were given, and then the outer 2, remember, are your derivatives. So there's always 4 parts. So I like to put them in parentheses or brackets just to kind of keep those together. Okay? All right. Let's look at number 12. One of the things that we test you on, well, actually so besides doing the regular rules that we just finished, there are 3 other types of problems that we like to test you on to see if you really know these formulas. So one of the types of problems is like this one, where you get a function like cosine x, sine x, or whatever, but then the other function is just using function notation. So it's not like a function that you can see like x squared or 3x minus 5. They're just calling it f of x. Okay, so I call these the kinds of problems where you have function notation and a function. So they kind of mix it up. Okay, so that's one type that we're going to do. The second type that's coming up on the next page would be using a table for the values. And then the third type is getting your values off of a graph. Okay, so those are the other 3 types that you guys need to be able to do, and we're going to do those right now. All right, so we have 2 function values. F of pi over 6 is 7, and the derivative of pi over 6 is negative 5. So they're giving you 2 values. They have to give you values when you have function notation, because otherwise they can't figure out things. So then they say g of x, and read this to yourself. This says g of x equals f of x times cosine of x. So that's a product rule right there. And then h of x, obviously, sine of x divided by f of x, that's going to be a quotient rule. Okay? So look at what they're asking you to find first. The derivative of pi over 6. Okay? So that means, first off, I have to find the derivative of g of x. Okay, So before I find this, now you guys don't have to do this step that I'm going to do right here, but it's helpful for those of you that need to kind of see the consistency. All right, so I always start with just find the derivative using x. Don't worry about pi over 6 for a minute, okay? That just gets jumbled up and it makes it kind of confusing. So what if I just asked you to find the derivative of this product, okay? Because here's g of x, f of x times cosine of x. All right, so we're just going to do the derivative using x. So remember the product rule. Take the derivative of the first term. Well, the derivative of f of x is just f prime of x. I don't have a function to tell you the derivative of, so I just use the notation times the second plus the first function, which is just f of x, and now times the derivative of the second, that I can do, negative sine of x. Okay? All right, so that is the product rule for this. And notice when there's a function notation, I just use function notation. If it's an actual function, then I can find the derivative of it. Okay, now that I have that, now this becomes a little bit easier because now we're just going to substitute in everywhere there's an x over here. Now we can put in the pi over 6. So again, you don't have to do this middle step, but I think it's helpful for some of you just to kind of be consistent and not let these numbers throw you off. All right, so all I have to do now is substitute in pi over 6 for every x. So just substituting in all of those for x, pi over 6. Okay, so the trig functions, I know the sine of pi over 6 and the cosine of pi over 6. What I don't know is f prime of pi over 6 and f of pi over 6, but that's why they gave that to me. So you're just going to substitute in those numbers. So f prime of pi over 6 they gave you is negative 5. And then what is the cosine of pi over 6? Okay, cosine of pi over 6 is the square root of 3 over 2 plus f of pi over 6 they gave you was 7. And negative sine of pi over 6, well, the sine of pi over 6 is 1/2, so that would be negative 1/2. And then all we have to do is simplify that. So multiply this together, that gives you negative 5 square root of 3 over 2, square root of 3 over 2. And then plus, and you got 7 times negative 1/2, so it's going to be minus 7/2. That's fine to leave it like that. Since you have a common denominator, we can write it this way. Okay? So there's your answer. All right, now, the next part says find h prime of pi over 6. Well, now we're doing the derivative of a quotient. So again, I would start with just h prime of x. So go ahead and do the quotient rule. Just use an x so it doesn't get so bogged down with the pi over 6's in it. So we're going to do the quotient rule. So we take the derivative of the top, which is the cosine of x, times the bottom. Bottom's just f of x, minus the top function, sine of x, times the derivative of the bottom. So since that's just f of x, we would just write f prime of x. And don't forget, all over the bottom squared. Okay? All right, so there's the quotient rule. So now I can, I think, a little bit easier substitute in the pi over 6. So I've got the cosine of pi over 6 times f of pi over 6 minus the sine of pi over 6 times f prime of pi over 6 all over, be careful in the bottom, is just f of x, so f of pi over 6 squared. Okay? All right, so now we can fill in some numbers. So h prime of pi over 6. So we're going to start with the cosine of pi over 6, which is the square root of 3 over 2, times f of pi over 6. Remember that was 7. minus the sine of pi over 6 is 1/2, and f prime of pi over 6 was -5. And all of that is over f of pi over 6, so 7 squared. Now slide that up a bit. All right, so what does that give us? Multiply this, we've got 7 square root of 3 over 2 minus, nope, it's going to be plus, negative times a negative, so plus 5/2, all over 49. Okay, so that equals 7 square root of 3 over plus 5 over 2. And then divided by 49 is the same thing as times, 1 over 49, right? So we actually end up with 7 square root of 3 plus 5 over 49 times 2, which is 98. Okay, so again, you're dividing by 49 is the same thing as multiplying by 1 over 49. So get rid of that complex fraction. All right, so these are good practice because, again, your calculator's not going to help you too much with this. You got to know the rule, and you have to understand what to do with the function notation versus an actual function itself. And that's legitimate. You can do, they can give you one of each, okay? All right, let's look at number 13 now. This is the second type, a table of values. Can you do what we just did using a table of values? Okay. All right, so be very careful with the notation. Okay, so let's look at A. A says take function f times function g, the derivative of it, at -1. So this is a product rule. Okay, so again, we're doing this at -1. So if this is the product of two functions, I'm going to start with the derivative of the first. So we would do the derivative of the first at -1 times the second at -1. So just f prime of -1 times g of -1. Derivative, not a derivative. Then plus the first function, just the function, so that's f of -1 times the derivative, so g prime of -1. Okay, so there's your product rule. Notice you got the derivative of f, regular g, regular f, derivative of g. That's the product rule. Now, when you go to your table, just make sure you're looking for the right numbers. So we're looking at when x is -1, so we're doing this last column. So f prime of -1 would be -3. G of -1 is right here. That's -1. Plus f of -1 is up here, 1. And then g prime of -1 is -1. So we end up with -3 times -1 is 3. And then 1 times -1 is a -1. So we end up with 2. Okay. Now, I want you to notice B. Do you see any derivative signs in B? Okay, B is just f of -1 divided by g of -1 plus 5. Those are just regular function values. There is no derivative work to be done here, and I'm just taking function values. So f of -1 is just the number 1. G of -1 is -1 plus 5. So we end up with 1/4. That is not a derivative problem, okay? And they like to throw those in to see if you're paying attention to the notation. Now, C, D, E, and F all have derivatives. They all have the little hashtag up there, hash mark. So those are all derivatives, okay? But that one you got to be careful of. All right, so let's look at C. C is addition, okay? If we're doing addition, there's no rule. We just do f prime of -1 plus g prime, right? Addition and subtraction, we just do it like it says. So f prime of -1 plus g prime of -1, okay? The only rules we have are product rule, quotient rule. Adding and subtracting, you just distribute those through. So f prime of negative 1 is negative 3 plus g prime of negative 1 is negative 1. So we get negative 4. Okay. Same thing with d. F prime of negative 1 minus g prime of negative 1. That's just a subtraction. So f prime of negative 1 is negative 3 minus g prime of negative 1 was negative 1. So this time we end up with negative 3 plus 1. So we get negative 2. All right, so now we're going back to product. So product rule, quotient rule. Okay, so now we're doing like we did in A. This is a product, but this time we're using 7. So I'm going to slide this up and just do the formula with you. So we always start with the derivative of the outside. So f prime of 7 times g of 7. And then f of 7, the original function, times the derivative of the outer. So that one. Okay? So that is the product rule. So now we're going to go up to 7. So we're using these numbers. So f prime of 7 is negative 163. Okay. G of 7 is negative 9. Plus f of 7, negative 407. I don't know who came up with these. WebWorks comes up with crazy numbers, so you'll probably have some crazy ones. And then lastly, g prime of 7, negative 1. Okay, so multiply negative 163 times negative 9. That gives you a positive 1467. And then we have a negative 407 times negative 1. That's a positive 407. So together that gives you 1874. Okay, so all depends on the numbers coming out of the table. So just be careful you're getting the right ones. All right, so now we're going to do quotient rule on part F. Okay, quotient rule. So remember, quotient rule starts with the derivative of the top. So g prime of 0 times the bottom, so f of 0, minus the top, g of 0, times the derivative of the bottom, all over the bottom squared. Okay. All right, so now we're going to the row that said, or the column with 0, so we're using these numbers. Okay. All right, so g prime of 0, so that is negative 1. I'll keep sliding this. Okay, negative 1. Then f of 0, that's the top number, negative 1, minus, now we need g of 0, that's negative 2. And then f prime of 0, that's negative 2. Oh, wait a minute, g of 0. Oh, they are both negative 2. Thought I wrote down the wrong number, negative 2. Double check that. All right, and then over f of 0, remember f of 0 was negative 1, so negative 1 squared in the bottom. So just be careful with your signs. You guys do this perfectly, and then you end up with wrong answers down here, so just watch it. So negative 1 times negative 1 is positive 1, minus negative 2 times negative 2 is a positive 4, over negative 1 squared is 1. So that's going to just give you negative 3. Okay? All right. So that was using a table. So now we're going to go back and look at the ones that have a function and a non-function problem. So look at number 14. And I know this one came right out of WebWorks. So look at the function you have. This is the thing, you've got to be able to read what's here. So this is x to the 12th power times h of x, right? So x to the 12th is an actual function that we can find the derivative of, but h of x is just function notation, okay? So again, I've got the product rule. One thing I can do the derivative of, the other I'm just going to have to use h prime of x, okay? But we're still going to do the product rule. So they're giving you some information. We'll use that once we do the derivative, and it wants us to find the derivative at -1. So remember what I said. Before you do that, just do the derivative and leave x in the problem. I think that's the easiest way to do these. So if we're doing a product, we'd start with the derivative of the first. Well, what is the derivative of x to the 12th? The derivative of x to the 12th would be 12x to the 11th, right? Power rule times the second. So we're just going to multiply that by h of x plus the first, we're going to leave that alone, x to the 12th, times the derivative of the second. So we'll just write that as h prime of x. All right, so there's your product rule. Now we can substitute in -1 for our x's. Now, be very careful with when you're raising -1 to a power, okay? We're plugging in -1 for any x. So this is 12 times -1 to the 11th power. Okay, you can do that on your calculator if you want. Then times h of -1, okay, plus -1 to the 12th power times h prime of -1. So there's a lot of, so that's why I said, if you did this first, it looks very confusing. So I think this is easier to just do it with x and then plug in your number. All right, so let's talk about this. You can put that right in your calculator just like that. Okay, so you do powers first. -1 to the 11th power. So when you take a negative number and raise it to an odd power, it's going to stay negative. So that's -1 times 12. So that is -12 right there. Okay. All right, then we have h of -1. So that's given to me. H of -1 is 3. Okay, plus -1 to a positive power will be a +1, right? Even numbers, so -1, you can do that in your calculator. Make sure you put the negative number in a parentheses, raise it to the 12th power, you will get 1. Times, and then h prime of -1 they also gave me, which is 6. So we have -12 times 3, which is -36, plus 6. So we end up with -30. Okay. These types of problems, it just really means that you understand these rules and you're understanding the notation. Okay. All right. So the very last problem, number 15, is using a graph. To me, when I see students do this, these are the ones you guys tend to think are the hardest because you're pulling the slope values off of a graph. So you actually have to find the slope by counting rise over run. Okay. And you're using the function value as well. So you have to be very careful with these and remember what it is that you're doing. So there's two problems here. We're going to find u prime of 1, where u of x is a product. And then we're going to do v prime of 1, where v is the quotient rule. So we're doing product rule, quotient rule, but we're going to use the graph to do that. So it tells you that the graph of the function f is given in blue, which is really the bottom 3 lines. So f is these lines down here. It's a piecewise function. And then it says g is given in red, and those are the two pieces that are up at the top. Okay? All right, so we're going to do u prime of 1. Now, remember what I said. If you want to start with u prime of x first, do that because that will help you with plugging in the ones. If you feel comfortable enough to just start with the ones, then you can skip this step. All right, so we're going to do the product rule f of x times g of x. So we're going to start with the derivative of the first, f prime of x times the second, g of x, plus the first function, f of x times the derivative of the second. Okay, so just keeping x in the problem. Then substitute in your ones. So now we can find u prime of 1. So that would be f prime of 1, g of 1, plus f of 1, g prime of 1. Okay? All right, so remember, g of 1 and f of 1 are the function values. What are the y values at 1? F prime of 1 and g prime of 1 are the slopes of those lines at 1. So slopes. So we're going to start with the slope at 1. Okay, so we're doing the blue line. That's the function f. Here is 1. What is the slope right there? So your line's going up, so it's a positive number. And just count your grid marks. So you went up 1 over 1, right? Up 1 over 1. So the slope of this line is 1. So that's f prime of 1. G of 1 is the ordered pair right there at that point. What is that ordered pair? That is the ordered pair 1, 2, 3, 1, 3, right? So G of 1 is the point or the y value of 3. F of 1 is the y value of this point. Well, that point is 1, 1. So f of 1 is 1. G prime of 1 is the slope of this line. What is the slope right here? Well, this line is coming down, so I know the slope is negative. Count your rise over run, so down 1 over 1. So the slope right here is negative 1. All right, so 1 times 3 is 3. 1 times negative 1 is negative 1. So the product of the derivative is 2. Okay. All right. So we're going to do the same thing for v prime, and we already have our numbers, so we don't have to kind of look at the graph again, but we can. But remember what I said. Let's start with v prime of x. If you want, do the quotient rule. So v is a quotient, f divided by g. So we would do f prime of x, the derivative of the top, times the bottom, g of x, minus the top, f of x, times the derivative of the bottom, all over the bottom squared. Okay? And now we can plug in what we're finding, so v prime of 1. So that would be f prime of 1 times g of 1 minus f of 1 times g prime of 1 over g of 1 squared. Okay? So, you can go back over here and get your points again, but we have them right here, so just put them in the right place. So we've got f prime of 1 times g of 1, so that's right here, right? So that's 1 times 3 minus, and then f of 1 times g prime of 1, those are those numbers, same numbers, 1 times negative 1. This time we're going to put it all over g of 1 squared. Okay, remember g of 1 is 3. So over 3 squared. So, and also there's a minus sign there, so we got to watch that. Okay, so now in the numerator, I have 3 times 1, and then this is going to be plus 1 over 9. 3 squared is 9, so we end up with 4/9. Okay. All right, so got a lot to work with on product and quotient rules. It all boils down to practice, practice, practice. The more you do it, the easier these become. Good news is you don't have to simplify too much, so that helps, okay? So keep working on these, work on your web work problems, and as usual, let me know if you have any questions.